morning, friends. In Thermodynamics chapter 12, we discuss about the specific heat capacity at constant volume and also at constant pressure. And also we did the relation between them, Cp minus Cv is equal to R. Right? Now, after that, what is the state variable and thermodynamic state variable? After that, we are also going to discuss about the different kinds of the thermodynamic process. The different kind of the thermodynamic process, that means here in one state variable we keep the constant, and whatever the change occurs during the process, that is known as the particular thermodynamic process. Like as the pressure constant, volume constant, temperature constant, right? Amount of the heat supplied is also constant, and internal energy of the system is constant. Right? So first, what is the state variable and also the thermodynamic state variable? Again, what is the state variable? And there are two kinds of the thermodynamic state variable. There is only informative question. Maybe ask the MCQ question from this portion. For that purpose, every equilibrium state of a thermodynamic system is described by specific value of some variables are known as the state variable. Again, every equilibrium state of thermodynamic system is described by the specific value of some variables are known as the state variable. Which type of the specific value of the some variable? Already we consider a piston cylinder arrangement. A gaseous system or the gas system is filled in a piston cylinder arrangement. So as the pressure and volume or the temperature changes of this gas, so pressure and volume are changes. So every state of this system is represented by the specific value of some macroscopic variable, like as what is the value of temperature, pressure, volume, internal energy. So this variable represent or they indicate the state of a thermodynamic substance. So this variable or the macroscopic variable are known as the state variable. Again, the definition of the state variable is that every equilibrium state of a thermodynamic system is described by specific value of some macroscopic variable is called the state variable. An equilibrium state of a gas is specified by the value of pressure, volume, temperature, and mass of a gas. In equilibrium, the state of the thermodynamic is specified by the value of the macroscopic variable, like as the pressure, volume, temperature, and mass of a system. Again, equilibrium state of a gas is specified by values of the pressure, volume, temperature, and mass of a gas. So in short, the state variable are the pressure, volume, temperature, and mass of the density of a gas are known as the state variable. After that, the thermodynamic state describes the equilibrium state of a system of the state variable. Thermodynamic state describes the equilibrium state of system of state variable. In equilibrium, what is the relation between the state variable? That is known as the equation of state. That means the relation between the state variable is known as the equation of state. That means we know the equation of state is PV is equal to mu RV. P is the pressure, V is the volume, T is the temperature, and U is quantity of a gas. So in short, that is the mass of a gas. So pressure, volume, quantity of a gas and temperature are known as the state variable, and the relation between the state variable that is known as the equation of state. By knowing the equation P is equal to mu RT, we can describe the state of a thermodynamic substance or the state of a system. So, relation between the state variable is known as the equation of state, and that is the P is equal to mu RT. From this equation, we can specify the state of a system. Right? Okay. Now, the thermodynamic state variable are two types: extensive variable and also the intensive variable. Here, sometimes the 1 mark MCQ question may be asked: which of the following is extensive or intensive variable? Again, the thermodynamic state variable are two kinds. One is extensive variable and second is the intensive variable. Now, extensive variable indicates the size of the system. Extensive variable indicates the size of the system. For example, the internal energy, volume V, total mass M, and work W are the extensive variable. Again, what is the difference between the extensive and intensive variable? Extensive variable indicates the size of the system. For example, internal energy, volume V, and total mass M and work are the extensive variable, which indicates the size of a system. Now, intensive variable does not indicate the pressure, temperature, and dimension of a system. Intensive variable does not indicate the pressure, temperature, and dimension of a system. Okay. Now, the variable that remain unchanged for each part are intensive variable. Again, the variable that remain unchanged or they remain constant for each part are intensive variable. What are the variables remain unchanged during each part of the system? That is known as intensive variable. And the variable whose value gets half in each part are extensive. In short, what are the variables remain unchanged for each part of the system are intensive, and what are the variables whose value are changed for each part of the system are extensive variable. The internal energy, volume V, and total mass M are the extensive variable. Again, the internal energy, volume V, and total mass M are extensive variable, while the pressure P, temperature T, and density ρ are intensive variable. Again, the pressure P, temperature T, and density are intensive variable, while the extensive variable are internal energy, volume V, and total mass. So in short, what is the extensive, what is the intensive? Extensive variable indicate the size of the system, while the intensive variable does not indicate the size of the system. Intensive variable remain unchanged for each part of the system, while the extensive variable are changed for in each part of the system. The extensive variable are internal energy, volume V, and mass M of the system, while the intensive variable are pressure P, temperature T, and density ρ are the intensive variable. Okay. After that, the thermodynamic process, different kinds of thermodynamic process. Explain different thermodynamic processes. The thermodynamic processes are as below. First is, in first process, we consider the temperature of a process is remain constant. The thermodynamic process during which temperature of the system remain constant is known as isothermal process. The thermodynamic process during which temperature of the system remain unchanged or the constant is known as isothermal process. Again, What is the isothermal process? The thermodynamic process during which temperature of the system remain constant or the unchanged. That is known as isothermal process. If we have the system in initial stage, the pressure is P1, volume is V1 and temperature is T1. Now we bring the system in other state in which the pressure is P2, volume is V2 and temperature is T1. That means the pressure and volume change but the temperature is unchanged. That means they remain constant. So this thermodynamic process is known as isothermal process. Okay. Now the second. The process during which pressure of the system remain constant. That is known as isoquaid process. Again, the thermodynamic process during which the pressure of the system remain constant is known as isoquaid process. Again, the thermodynamic process during which the pressure of a system remain unchanged or the constant. Such process is known as isoquaid process. Clear? Isothermal, temperature constant. Isoquaid, pressure constant. Now, next is the process during which volume of the system remain constant. The process during which volume of the system remain constant is known as Isoquaid process. Again, the process during which volume of the system remain unchanged or the constant is known as Isoquaid process. Okay. Now already we discussed about the state variable. And equation of the state is PV is equal to mu R. Right? Okay. So first we keep the temperature constant. So PV is equal to constant for isothermal process. Because the mu is the quantity of a gas, R is the universal gas constant, and we keep the temperature constant. So for isothermal process, the PV, that means the product of the pressure and volume is remaining constant. Or in other words, the pressure is inversely proportional to the volume. Okay. Now, second type of the process, here the pressure is constant. So volume is directly proportional to its temperature. Volume is directly proportional to its temperature. First, for isothermal process, temperature constant, so PV is equal to constant. For isothermal process. Or in other words, the pressure is inversely proportional to the volume. Inversely proportional to the volume for isothermal process. From this equation of state, PV is equal to mu RT, temperature is constant, therefore left hand side of the right hand side of this equation is constant, P is equal to constant, therefore P proportional to 1 upon V. Now second process is the pressure of a system is constant. Therefore, P constant, therefore V is equal to mu RT upon P. Therefore, V proportional to the temperature T. V proportional to the temperature T. The thermodynamic process during which the pressure of the system remains constant is the isoquaid process, and for isoquaid process, P is constant, therefore volume is directly proportional to the temperature. As the temperature increases, volume is also increases. As the temperature decreases, volume is also decreases. Right? Okay. Now, for third process, the process during which the volume of the system remains constant. Volume is constant. So from this equation, PV is equal to mu RT. Therefore, volume is constant, P is equal to mu RT upon V. Therefore, the pressure is directly proportional to the temperature of the system. for isoquaid process. Therefore, the process during which the volume of the system remains constant, this process is known as the isoquaid process, and for isoquaid process, the pressure is directly proportional to its temperature. Therefore, the pressure is directly proportional to the temperature. Now, a process in which the system undergoes the physical changes in such a way that heat is neither allowed to enter the system from the environment or the surrounding, nor allowed to leave the system to the surrounding. Such process is known as the adiabatic process. Again, the process in which a system undergoes physical changes in such a way that heat is neither allowed to enter the system from surrounding, nor allowed to leave the system to surrounding. Such process is known as adiabatic process. So in short, the exchange of the heat is constant. That means there is no exchange of the heat take place. If the exchange of the heat does not take place, what's happened? The internal energy of a system remains same. Internal energy of a system is also remain constant. Delta U is also constant. Therefore, the change in internal energy of the system is zero. Therefore, whatever the amount of the heat supplied is directly converted to the work done. Is directly converted to the work done from the first law of thermodynamics. Again, about the adiabatic process, we can also add this definition like this way: the thermodynamic process during which the exchange of the heat between the system and surrounding is zero. Such process is known as the adiabatic process. Or in other words, the process in which system undergoes a physical changes in such a way that heat is neither allowed to leave the system to the surrounding, or neither to enter the system from the surrounding. Again, a process in which a system undergoes physical changes in such a way that heat is neither allowed to enter to the system from surrounding, nor allowed to leave the system to the surrounding. Such process is known as the adiabatic process. Such process is known as the adiabatic process. For adiabatic process, the amount of the heat does not exchange or take place. Therefore, Q is equal to 0. Therefore, Q is equal to 0. That means the work done is. So, from the first law of thermodynamics, as the exchange of the heat takes place is 0. Therefore, the change in internal energy of a system is also 0. We discuss it later about this when we discuss about the cyclic process. Now the next process. The process in which the system undergoes a series of changes which returns the system back to its initial state. Such process is known as the cyclic process. Again, the process in which the system undergoes series of changes which return the system back to its initial state is known as cyclic process. Now, what is the example of the cyclic process? At present, we are using the electric engine in train, but in past, the steam engine are used. Right? How the water is converted into the steam in railway. So here the one tank of water, one water, this water is comes into the other tank. The fires take place below this tank. So water is directly converted into the steam. This steam or this water or this tank is the piston cylinder arrangement. As the water enter in this cylinder, that is converted into the vapor, therefore the piston moves up. Therefore what's happened? The half rotation of the wheel of a train is take place. This steam is taken out, new water is entered, again converted into the steam. So half rotation of the wheel take place. So whatever the vapor is taken out from the cylinder, again cool down and again convert into the water. So initial state of this thermodynamic substance is water. This undergoes the thermodynamic changes. This water is converted into the vapor at high pressure and high temperature. Again, there is the cool down. So again the state is changed from vapor to the liquid, that means the water. Again this water is filled in the piston cylinder arrangement. So this way the steam engine is worked. So there is the cyclic process. Again, a process in which the system undergoes series of changes which return the system back to its original state. Such process is known as cyclic process. Also in this chapter we discuss about the cyclic process in detail, and also we had to obtain the equation of the work done during the cyclic process. Clear this? Again we repeat it. What is the isothermal process? The process during which temperature of the system remain constant. Is the temperature constant? Therefore PV is equal to constant and pressure is inversely proportional to the volume of a system. Second type of the process is the process during which the pressure of the system remain constant. That is known as the Isoquaid process. From equation of the state, pressure is constant, therefore the volume is directly proportional to the temperature of a system. Clear? Now third, the process during which the volume of system remain constant. Volume is constant, therefore the work done is zero. Work done is zero. The process during which the volume of the system remains constant is known as the Isoquaid process. And from Isoquaid process, volume is constant, therefore pressure is directly proportional to the temperature. Now fourth type of the thermodynamic process, a process in which the system undergoes the physical changes in such a way that the heat is neither allowed to enter the system from surrounding nor allowed to leave the system to the surrounding. That means the exchange of the heat does not take place. That means the amount of the heat is zero. Delta Q is equal to constant or the zero. So such process is known as the adiabatic process. In adiabatic process, the exchange of the heat does not take place. That means neither the heat allowed to enter the system from the surrounding, nor the heat allowed to leave the system to the surrounding. Such process is known as adiabatic process. For adiabatic process, delta Q is constant or the Q is constant. Now, next is the cyclic process, a process in which the system undergoes series of changes which returns to the system back to its original state. Again, the process in which system undergoes series of changes which returns the system back to its initial state. Such process is known as cyclic process. Now we also we make the detailed study about this different kind of the process, and we get the relative equation for this type of the different thermodynamic process. Okay?